Alright, section 5.3 is on page 335, talks about ellipses. The standard equation of an ellipse centered at the origin, that's key. Again, in section 5.5, that's going to change, is either x squared over a squared plus y squared over b squared equal 1, or x squared over b squared plus y squared over a squared equal 1. The book likes to justify those because they set a to be bigger than b and vice versa. We don't. It doesn't matter. We say that's an equation of an ellipse right there. That's more than enough. The foci would be, they call them C in this section. I'd rather call them F, but they call them C. And that's the square root of a squared minus b squared, or b squared minus a squared. And the easiest way to remember, take the larger minus the smaller. Now there are a few things that they want: vertices, foci, co-vertices, major, minor. I'm just going to point those out as we move along. I'd like to jump straight to the graph, sketch a graph. And I'm making those up. So this is how you look at this. You say, okay, underneath x is a 4, a squared. What do you square to get a 4? 2. So that means start at the origin, move 2 in the x, left and right. Label these points. Those points are on the ellipse. And if you look at the y, what's underneath y is a 9. To figure out what b is, what do you square to get 9? Plus or minus 3. So you go 1, 2, 3, and 1, 2, 3. Connect those with a smooth curve, and that would be your ellipse. There it is, done. The center is at 0, 0. That's simple. The vertices are always the stretched. You'll notice, if you're talking about an ellipse, there is a side that's longer than the other. The stretched, that's 0, 3, and 0, negative 3. They say those are the co-vertices. This is the first book that uses those. Foci, and that's C. And here, the foci are always on the stretched side. The stretched side, they call that the major axis. Major axis. And the smaller stretch is called the minor. Things you should know. We're not asking for those, but as you move on, they start giving you those. All what we want is the center we did, the vertices we did, and the foci. And I know there's going to be on the y-axis because the foci must be on the stretch, the major axis. And how do you find the foci? You say c equal the square root of, and it's simple, the larger minus the smaller. 9 minus 4 is radical 5. Radical 5 is a number between 2 and 3. Go up 1, 2, between 2 and 3. Label that, and there it is. So that's radical 5 and negative radical 5. There it is, done. That's all you have to do. So when I get to the next problem, the next example, sketch a graph. Graphing is the easiest part. I know it's hard to believe, but it is. What do you square to, so you go to the x, what do you square to get 9? 3, right? So we're gonna move, I need that to be a bit bigger. So let me move it to the right. Okay. So if I move 3 in the x, 1, 2, 3, and negative 3, that's what you square to get 9. And if I was to say, what do you square to get 25? That will be 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. If you connect this with a smooth curve, there's my ellipse. So again, I look at the stretched side. This is 25. I already know without the graph that, you know what? That's the major axis. And this less stretched is the minor. And that's important because the vertices the vertex, the center is 0, 0. All of these are. But the vertices are always either the endpoints on the x or the y, depending on which is the major. So that will be 0, 5, and 0, negative 5. And the foci, automatically, I know they are along the y-axis, and that is the square root of 25 minus 9, which is square root of 16, that's 4. So 1, 2, 3, 4 units, and 1, 2, 3, 4 units. The foci have certain properties that we will discuss much later. And that pretty much is it. I'm going to go to the third problem, and I don't know why we did that. Let me fix that. So let's say the problem looks like this. The book likes to rotate on those. I like to put x first, y after. It doesn't matter. So let's say the problem looked like this. Now, one thing I didn't mention yet because it didn't come up. The key to the equation is the 1. I didn't mention about that because, you know, we didn't know much. We were still thinking about it. So the key is for this to be a 1 for any of this to work. So what's underneath y squared? A 1. What does that mean? That means let me enlarge this a bit and move it to the right like I did the rest. Here we go. That means if I really look at this, I'm going to start at the origin. I'm going to move 3 to the right, 3 to the left, 1 up, 1 down. Connect this with a smooth curve. There's my graph. My center in this section is going to be 0, 0. Vertices. Now I am aware that the vertices are what? On the stretch side, the major axis in this case is right there. And the minor axis is right there. Well, it's going to be 3, 0, and negative 3, 0. And the foci will be on the x-axis as well because they're always on the stretch side. And c will equal the square root of 9 minus 1, which is radical 8. And that's 2 radical 2. So radical 8 is a number between 2 and 3. Anywhere between 2 and 3, we are fine. And anywhere between 2 and 3, and that's 2 radical 2 and negative 2 radical 2. And there it is. That pretty much takes care of it. Now, I have another set of problems. 2 problems and an exception. What the difference is between this problem and what we just did is that this doesn't equal a 1. You make sure of that before you proceed. You ensure that this is a 1. If it's not a 1, you could force it to be a 1. And that makes this x squared over 4 plus y squared over 12 equaling a 1. So, what do you square to get a 4? Well, 2 to the right, 2 to the left. That's easy. What do you square to get 12, radical 12, a number between 3 and 4? 1, 2, 3, 4, a number between 3 and 4. And if it's not an integer, I would label that, or 2 radical 3, whatever you want. And 1, 2, 3, 4, a number between 3 and 4, because 4 is 16 and 3 is 9. And you label that as negative radical 12. Connect this with a smooth curve. There's the ellipse. Graphing is the easy part, labeling is the hard part. I notice the major axis, it's either the x or the y. That's the major. And the minor is right there. I really don't need the minor, but I'm just pointing that out because it does come up every now and then, and we want to make sure we know what it is. The vertices, the center is at 0, 0. That's simple. The vertices, since the stretches along the y, that's 0, 2 radical 3, and 0, negative 2 radical 3. The foci are also on the x-axis, on the y-axis. And how does that work? C equal the square root of 12 minus 4. c equal the square root of 8, that's 2 radical 2. So a number between 2 and 3, 1, 2, there it is, and 1, 2, anywhere in there will accept. That will be 2 radical 2 and negative 2 radical 2. And there it is. Now those are called co-vertices. This is the first book that uses that analogy. I've never seen that before. But, you know, not that hard. Alright, and let's look at that last piece. Again, the goal is to make this a 1. It's not a 1. We could force it to be a 1. That's easy. And this is x squared. 4 divides 125 times. 25 divides 104 times. So, what is squared to get? I need to center that. To get a 25, obviously a 5. That's simple. So we move 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Along the y, what is squared to get a 4, 2. And connect this with a smooth curve. So what this tells me, here's the major axis. Here's the minor axis. And the center is at 0, 0. That's simple. I could see that. The vertices are at, and what do we notice? Those endpoints, basically, right there. What is the square of 5 and a negative 5? And the foci must be on the x-axis because the stretch is along the x. You take c to equal the square root of 25 minus 4. That's square root of 21, a number between 4 and 5. 1, 2, 3, 4. And 1, 2, 3, 4. So that is square root of 21 and negative square root of 21. I get to the last problem, and what do I notice? The center is at the origin. What do you square to get a 4? 2. And what do you square to get a 4? 2. And I'm a bit confused because I'm thinking, wait a minute. There's no stretching. Well, yeah, that's right. That's how a circle looks like. This is not an ellipse. This is actually x squared plus y squared equal a 1, which is a circle centered at the origin with a radius of 2. So a radius has those two equal, and that's why there's no stretching. There's, no foci or anything like that. Now we're going to go to the book. On page 346, it says, use the graph to write the equation of an ellipse. Well, if it's centered at the origin, if you write down what you know, you will be amazed by how much you know. So first things first. X. The stretching on the x is 1, 2, 3, 4, 5, 6. And the y, 1, 2, 3, 4, 5. That is a fine answer for the homework and the test. Or you could say, if you wish, x squared over 36 plus y squared over 25 equal 1. Here they're giving you some information about the graph. They want you to come up with the equation, which turns out to be easier. Not that the graphing and labeling was hard, just this is easier in this direction. You just have to see it. Number 4. And now a rough sketch, even though they're not asking for it, will really help plenty, just to visualize where things are. It says, use the given information to write an equation of the ellipse. Okay, so center at the origin, automatically I have x squared plus y squared equals a 1. The question is, what's going to go underneath x? What's going to go underneath y? It says vertex at 0, 8. So let's say this is 2, 4, 6, 8. That's a vertex, right? And a co-vertex at 2, 0. So the graph looks something like this. Well, The vertex is always at the major. Do you see if you start at the origin, you really move 8 units along the y? And the co is always the minor. If that's a 2, do you see that you moved from the origin 2 units to the right? There it is. Again, the graph is not part of the problem. You really don't need to graph. I suggest you do that if you're having a hard time with this, and if you can't visualize it. You will be amazed by how easy this becomes. And let's look at the next problem. It says, find me an equation of an ellipse. Alright, I'm going to sketch a rough graph again. Right there. Roughly put down what's given. A vertical minor. The minor is vertical. The shorter is vertical. Has a length of 10. This length is 10. I have x squared plus y squared equal a 1. The minor is vertical, so they're saying you moved 10 units. It has a length of 10 units. Doesn't that mean from the origin you really moved 5 above and 5 below? And what else? And the horizontal major axis, the horizontal is major, and it has a length of 14. If this is 14, doesn't that mean that this is 7 and this is 7? Wouldn't that be the equation right there? Again, it's very simple to come up with the solution. If you could visualize the graph, you really don't have to write the graph down, but if you could visualize it either in your head or just plot what I'm doing, and you'll be more than happy with the outcome. How about this problem? Again, x squared plus y squared, and there's a 1 there all the time. It says the x intercepts at 5 and negative 5, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Doesn't that mean you moved 5 units to the right and 5 units to the left? And the foci is located at 4 and negative 4, 0. Now, call this whatever you want to call it. Call it, I always call it a squared, regardless. Isn't the foci the square root of the larger minus the smaller? Isn't the larger the 5 squared? And a squared is what I'm looking for. And how many units is that? How many units was the foci? Wasn't the foci 4 units? Isn't this a radical equation? Do we not solve radical equations? Square both sides and switch those. Doesn't that mean that a squared equal 25 minus 1 is 21? And there it is. There's my equation. I just want the equation and I just found it. I could find anything else I need, but that's all they want. And number 10 would be my last example. The rest is graphing, but we did graphing already. So, if I take the major axis has a length of, the major axis of length 8. Okay, but I'm not sure where is it. Is it on the x or the y? I'm not sure. That's why I'm going to go for the foci are located at 0, 2 and 0, negative 2. The foci, aren't the foci always on the stretch side? That means the stretch is along the y, and that's 8 units. If this is 8 units, doesn't that mean this is 4 and this is 4? And I know the equation is x squared plus y squared equal a 1. So automatically I figured this is over 4 squared, right? What's missing? I need to know what this is. I always call it a. Well, they told us the foci. They said the foci is at 0, 2. So they're saying c equals, which is the square root of the larger in this case is the 4 squared minus a squared, and that happens to be 2 units. And how do you solve that? You square both sides. We solved radical equations before. Swap those. And wouldn't that mean that a squared equals a 12? And there's my equation. A very simple section, I think. It's bad when you do the shifting, and if you really get this out of the way, even the shifting turn out to be a special case of this. I'll show you a nice trick around it. And there's the homework, and in case you're missing that, number 1 through 9 you follow directions just like I did. On numbers 11 through 23, you're going to ignore all the directions in the book. You're going to take number 11, 13, 15, 17, 19, 20, 1, and 23. And what you're going to do, you're going to follow this direction in the homework stating graph, label the center, vertices, and